Greetings and welcome to part 3 of my hardcore series. First of all, I want to apologize for not uploading at all lately. I got sick, then I wanted to take some time off, have some form of holiday. And I was thinking about the course of my channel. Using this artificial voice is indeed a way to go. I am not sure if it is ideal though. But currently it is almost impossible for me to use a microphone. I don't have my own separate room and I am pretty much in constant noise. Which would be way worse than this approach. Not to mention that I do not like my real voice, even though my dear friend Victoria keeps telling me that my voice is fine. And I would have to practice talking as well. I am shy and mostly quiet person. So maybe there will be a big shift in my content in the future, no idea when, sadly. Anyway, big thanks to those of you who stick around and watch my videos, it really means a lot. Both part 1 and part 2 got around 30 views, which is not a lot, but I do this mostly for fun and even 10 views is something unexpected for me. But now I shall talk a bit about the gameplay in this episode. So I am going to build a house. Or at least try to. I want to use many types of wood planks to make it look less boring, which means that a big portion of this video is me gathering wood. I do want to show all of the tree chopping so that you do not think that I might be cheating. Here in Java Edition, darn easy to cheat, but where is the fun in that? I like to swing my axe. Anyway, I want to talk about weather. The heat in last few weeks was pretty intense by my standards and my opinion on climate change is that I can literally feel it. Heat waves are becoming more frequent and longer globally, and scientists say that human-caused climate change has an influence on all of them. While models estimate greenhouse gas emissions increase temperatures in this heat wave by 2 degrees Celsius, historical weather records indicate that the heat wave would have been 4 degrees Celsius cooler in a world that had not been warmed by human activities. The UK last week experienced high temperatures that climbed over 40 degrees Celsius, 104.5 degrees Fahrenheit, for the first time on record on the 19th of July. And on the 23rd of July, in my country, Czech Republic, we reached 36.3 degrees Celsius, 97.3 degrees Fahrenheit. And honestly, solutions against this that are proposed by European Union seem useless in my opinion. Especially when China releases around a third of the worldwide carbon dioxide into the atmosphere by using way too many coal power plants. And we here can't do much about it. But I am not a scientist or a politician. I do read science papers and articles online, but they might be wrong. So make sure to check different sources yourself. What else do I talk about? Oh, I know. Bees aren't the only insects pollinating red clover. Moths do about a third of the flower visits after dark, new research suggests. The findings, detailed in the July biology letters, come as a surprise, since almost all the credit for pollination of red clover has gone to bees. The discovery highlights what researchers may be missing during the night shift of plant pollination, including a previously unknown benefit the moth pollination bestows on the clover. A boost in seed production. Clover is a valuable agricultural plant and has received a lot of study, yet none of those studies have said anything about the possibility of moth pollination. To track pollinator visitation to grassland plants, the team set up 15 time-lapse cameras in the Swiss Alps. You can't feasibly have someone stand there for 24 hours and record consistently what is visiting a flower. Fortunately, you can do that with cameras. Most of these nectar seekers, around 61%, were bumblebees. But a substantial proportion, 34%, were moths, mostly large yellow underwings visiting in the early morning hours. butterflies and neither a wasp or another bee species rounded out the other 5% of visits. In other news, astronauts might one day dine on salad grown in asteroid soil. Romaine lettuce, chili pepper and pink radish plants all grew in mixtures of peat moss and faux asteroid soil, researchers report in the July Planetary Science Journal. Scientists have previously grown crops in lunar dirt. But the new study focuses on carbonaceous chondrite meteorites, known to be rich in volatile sources, especially water. These meteorites, and their parent asteroids, are also rich in nitrogen, potassium and phosphorus, which are key agricultural nutrients. Pulverizing these types of asteroids, perhaps as part of space mining efforts, could potentially provide a ready supply of farming material in space. Peat moss keeps soil loose and improves water retention. In all mixtures with peat moss, the plants grew. Faux asteroid soil on its own, however, compacted and couldn't retain water, so plants couldn't grow. Next, astroecologist Sherry Fieber-Bayer will try growing hairy vetch seeds in that faux asteroid dirt, let the plants decay and then mix the dead plant matter throughout the soil. That, she says, could ensure that the soil doesn't compact. Plus, seeds weigh a lot less than peat moss, making them easier to carry to space to help with any future farming attempts. And since I am talking about space, a fast-spinning neutron star south of the constellation Leo is the most massive of its kind seen so far, according to new observations. The record-setting collapse star, I will put the name on screen, weighs about 2.35 times as much as the Sun, researchers report. That's the heaviest well-measured neutron star that has been found to date, says study co-author Roger Romani, an astrophysicist at Stanford University. If a neutron star grows too massive, it collapses under its own weight and becomes a black hole. These measurements of hefty neutron stars are of interest because no one knows the exact mass boundary between neutron stars and black holes. It's defining the boundary between the visible things in the universe and the stuff that is forever hidden from us inside of a black hole. A neutron star that's on the hairy edge of becoming a black hole, just about heavy enough to collapse, has at its center the very densest material that we can access in the entire visible universe. This heaviest neutron star resides 20,000 light-years from Earth, far above the galaxy's plane in the Milky Way's halo. The neutron star emits a pulse of radio waves toward us each time it spins, so astronomers also classify the object as a pulsar. First reported in 2017, this pulsar spins every 1.41 milliseconds, faster than all but one other pulsar. That's why Romani and his colleagues chose to study it. The fast spin led them to suspect that the pulsar might be unusually heavy. That's because another star orbits the pulsar, and just as water spilling over a water wheel spins it up, gas falling from that companion onto the pulsar could have sped up its rotation while also boosting its mass. Observing the companion, Romani and his colleagues found that it whips around the pulsar quickly, at about 380 kilometers per second, 236 miles per second. Using the companion's speed and its orbital period of about 6.5 hours, the team calculated the pulsar's mass. Clouds of sand can condense, grow, and disappear in some extraterrestrial atmospheres. A new look at old data shows that clouds made of hot silicate minerals are common in celestial objects known as brown dwarfs. Clouds come in many flavors in our solar system, from Earth's puffs of water vapor to Jupiter's bands of ammonia. Astronomers have also inferred the presence of extrasolar clouds on planets outside the solar system. But the only extrasolar clouds that have been directly detected were in the skies of brown dwarfs. Dim, ruddy orbs that are too large to be planets but too small and cool to be stars. In 2004, astronomers used NASA's Spitzer Space Telescope to observe brown dwarfs and spotted spectral signatures of sand, more specifically, grains of silicate minerals such as quartz and olivine. A few more tentative examples of sand clouds were spotted in 2006 and 2008. Floating in one of these clouds would feel like being in a sandstorm. If you could take a scoop out of it and bring it home, you would have hot sand. Astronomers at the time found 6 examples of these silicate clouds, and theoretically, there should be a lot more than 6 brown dwarfs with sandy skies. But part of the Spitzer telescope ran out of coolant in 2009 and was no longer able to measure similar clouds' chemistry. Then, scientists, while looking at other data from this telescope, found unpublished or unanalyzed data on dozens of brown dwarfs. So scientists analyzed all of the low-mass stars and brown dwarfs that Spitzer had ever observed, 113 objects in total, 68 of which had never been published before. Not every brown dwarf in the sample showed strong signs of silicate clouds. But together, the brown dwarfs followed a clear trend. For dwarfs and low-mass stars hotter than about 1,700 degrees Celsius, 3,100 degrees Fahrenheit, silicates exist as a vapor and the objects show no signs of clouds. But below that temperature, signs of clouds start to appear, becoming thickest around 1,300 degrees Celsius, 2,400 degrees Fahrenheit. Then the signal disappears for brown dwarfs that are cooler than about 1,000 degrees Celsius, 1,800 degrees Fahrenheit, as the clouds sink deep into the atmospheres. The finding confirms previous suspicions that silicate clouds are widespread and reveals the conditions under which they form. Because brown dwarfs are born hot and cool down over time, most of them should see each phase of sand cloud evolution as they age. Now back to stuff about me for a bit. I have been playing Terraria quite a lot lately, not sure if I want to make content from it though. But if you never played it, highly recommend. It is kind of like 2D Minecraft, but with way more bosses, way more ores. Copper is actually useful in Terraria. You can use mana and magic weapons. One tip I have for you is to build platforms before summoning the starting bosses. Especially the Eater of Worlds. Have a few layers of platforms, otherwise the worm circles around you too easily and you are screwed. So if you get kind of bored of Minecraft, seems like one of the good options. Sure, you can always mod Minecraft, but there are people out there who played all of the good mod packs out there. Another game I was playing is Soapbox Race World. I have a few videos about it on my channel. It is basically Need for Speed World, but without EA trying to steal your wallet. It is purely community driven. My favorite server is Free Roam Spark server. That server has many added cars, so anyone can pick their favorite or have a huge collection. Another tip I have for you, do not bother with races, do pursuit outruns. It gives you way more money, but you need to be good at escaping police. And last game I started playing very recently is on Roblox. It is called Mall Tycoon. Very fun game, but I would call it relaxing. Do not expect any action here. You buy a mall, it makes you money, you upgrade the mall, it makes more money. But playing it while watching YouTube videos, if you are on a computer, that is, very good experience. Now some slightly scary news. Large wildfire on the Germany and Czech Republic border is spreading and threatening to destroy a forested national park popular with tourists. The fire in the region, called Bohemian Switzerland on the Czech side and the Saxon Switzerland National Park on the German side, started on the 24th of July. It had seemed to be under control but spread again on the 28th of July, German news agency reported. 8 firefighting helicopters were working to douse the flames in the hilly and rocky region that is difficult to access and where about 250 hectares, 618 acres, of forest were burning during this Thursday. Today, according to satellite images, the fire affected an area of 1,060 hectares, 2,619 acres, and the fires are still not under control, even after a week. Despite our repeated appeals, 2 irresponsible men and 1 woman went to this area in the early evening on the 30th of July, through places that have not yet been extinguished. The police officers expelled them from the national park and finally resolved the matter by negotiation, the police officers said. In addition, the national park rangers found a place in the forest where someone had made a campfire, even though there was this forest fire short distance away. It's absolutely incredible what a group of people like this can do, and it makes me sad, said the director of the National Park Service. In other news, German, Hungarian and Italian fighter aircraft will take up air patrols over the Baltic region as part of NATO's air policing mission starting on the 1st of August. For the coming months, for Hungarian JAS-39 fighter aircraft and some 80 personnel will lead the mission out of air base in Lithuania, while 4 German Eurofighter aircraft will fly out of Estonia. They will be joined by Italian Eurofighters based in Poland. The new contingents replace Belgian, French and Spanish units that have been patrolling the region since April. After several months at Lithuania, Czech Air Force jets will continue their deployment through the summer. Allies have taken turns guarding the skies over Estonia, Latvia, and Lithuania since they joined NATO in 2004, as the 3 countries do not have their own fighter aircraft. Anyway, now I would like to talk about artificial intelligence. Fiction is full of robots with feelings. But in real life robots have no feelings. There might be a way, though, to give robots feelings, say neuroscientists Kingston Mann and Antonio Damasio. Simply build the robot with the ability to sense peril to its own existence. It would then have to develop feelings to guide the behaviors needed to ensure its own survival. So Mann and Damasio propose a strategy for robots or human-like androids. At its core, this proposal calls for machines designed to observe the biological principle of homeostasis. That's the idea that life must regulate itself to remain within a narrow range of suitable conditions, like keeping temperature and chemical balances within the limits of viability. An intelligent machine's awareness of analogous features of its internal state would amount to the robotic version of feelings. Such feelings would not only motivate self-preserving behavior, Mann and Damasio believe, but also inspire artificial intelligence to more closely emulate the real thing. Typical intelligent machines are designed to perform a specific task, like diagnosing diseases, driving a car, playing chess. But intelligence in one arena isn't the same as the more general human-like intelligence that can be deployed to cope with all sorts of situations, even those never before encountered. Researchers have long sought the secret recipe for making robots smart in a more general way. In Mann and Damasio's view, feelings are the missing ingredient. Feelings motivate living things to seek optimum states for survival. An intelligent machine with a sense of its own vulnerability should similarly act in a way that would minimize threats to its existence. To perceive such threats, though, a robot must be designed to understand its own internal state. Mann and Damasio say the prospects for building machines with feelings have been enhanced by recent developments in 2 key research fields, soft robotics and deep learning. Rather than having to hard-code a robot for every eventuality or equip it with a limited set of behavioral policies, a robot concerned with its own survival might creatively solve the challenges that it encounters. Basic goals and values would be organically discovered, rather than being extrinsically designed. But back to human activity, sunlight may have helped remove as much as 17% of the oil slicking the surface of the Gulf of Mexico following the 2010 Deepwater Horizon spill. That means that sunlight plays a bigger role in cleaning up such spills than previously thought, researchers suggest. When sunlight shines on spilled oil in the sea, it can kick off a chain of chemical reactions, transforming the oil into new compounds. Some of these reactions can increase how easily the oil dissolves in water, called photodissolution. The most important factors in photodissolution, the researchers found, were the thickness of the slick and the wavelengths of light. Longer wavelengths, toward the red end of the spectrum, dissolved less oil, possibly because they are more easily scattered by water than shorter wavelengths. How long the oil was exposed to light was not as important. What impact the sunlight-produced compounds might have on marine ecosystems, however, isn't yet known. Peeking inside an animal's ear, even a fossilized one, may tell you whether it was warm-blooded or not. Using a novel method that analyzes the size and shape of the inner ear canals, researchers suggest that mammal ancestors abruptly became warm-blooded about 233 million years ago. Warm-bloodedness, or endothermy, isn't unique to mammals. Birds, the only living dinosaurs, are warm-blooded too. But endothermy is one of mammals' key features, allowing the animals to regulate their internal body temperatures by controlling their metabolic rates. This feature allowed mammals to occupy environmental niches from pole to equator, and to weather the instability of ancient climates. In all vertebrates, the labyrinth of semicircular canals in the inner ear contains a fluid that responds to head movements, brushing against tiny hair cells in the ear and helping to maintain a sense of balance. That fluid can become thicker or thinner depending on body temperature. Mammals have very unique inner ears. Compared with cold-blooded vertebrates of similar size, the dimensions of mammals' semicircular canals, such as thickness, length, and radius of curvature, are particularly small. By contrast, fish have the largest for their body size. In warm-blooded animals, the fluid becomes less viscous, and the canals may have shrunk to compensate. If so, it might be possible to trace how the shape of fossilized inner ear canals changed over time to discover when warm-bloodedness emerged in the mammal lineage. 2 billion years of volcanic eruptions on the Moon may have led to the creation of many short-lived atmospheres, which contained water vapor, a new study suggests. That vapor could have been transported through the atmosphere before settling as ice at the poles. Since the existence of lunar ice was confirmed in 2009, scientists have debated the possible origins of water on the Moon, which include asteroids, comets, or electrically charged atoms carried by the solar wind. Or, possibly, the water originated on the Moon itself, as vapor belched by the rash of volcanic eruptions from 4 billion to 2 billion years ago. It's a really interesting question how those volatiles, such as water, got there, says Andrew Wilkowski, a planetary scientist at the University of Colorado Boulder. We still don't really have a good handle on how much are there and where exactly they are. Wilkowski and his colleagues decided to start by tackling volcanism's viability as a lunar ice source. During the heyday of lunar volcanism, eruptions happened about once every 22,000 years. Assuming that water constituted about a third of volcano spit gases, based on samples of ancient lunar magma, the researchers calculate that the eruptions released upward of 20 quadrillion kilograms of water vapor in total, or roughly the mass of all the water in the Great Lakes. Some of this vapor would have been lost to space, as sunlight broke down water molecules or the solar wind blew the molecules off the moon. But at the frigid poles, some could have stuck to the surface as ice. For that to happen, though, the rate at which the water vapor condensed into ice would have needed to surpass the rate at which the vapor escaped the moon. The team used a computer simulation to calculate and compare these rates. The simulation accounted for factors such as surface temperature, gas pressure, and the loss of some vapor to mere frost. About 40% of the total erupted water vapor could have accumulated as ice, with most of that ice at the poles, the team found. Over billions of years, some of that ice would have converted back to vapor and escaped to space. The team's simulation predicts the amount and distribution of ice that remains. And it's no small amount. Deposits could reach hundreds of meters at their thickest point, with the South Pole being about twice as icy as the North Pole. The results align with a long-standing assumption that ice dominates at the poles because it gets stuck in cold traps that are so cold that ice will stay frozen for billions of years. There are some places at the lunar poles that are as cold as Pluto. Volcanically sourced water vapor traveling to the poles, though, probably depends on the presence of an atmosphere. An atmospheric transit system would have allowed water molecules to travel around the moon while also making it more difficult for them to flee into space. Each eruption triggered a new atmosphere, the new calculations indicate, which then lingered for about 2,500 years before disappearing until the next eruption some 20,000 years later. If lunar ice was belched out of volcanoes as water vapor, the ice may retain a memory of that long-ago time. Sulfur in the polar ice, for example, would indicate that it came from a volcano as opposed to, say, an asteroid. Future moon missions plan to drill for ice cores that could confirm the ice's origin. Looking for sulfur will be important when thinking about lunar resources. These water reserves could someday be harvested by astronauts for water or rocket fuel, the researchers say. But if all the lunar water is contaminated with sulfur, that's a pretty critical thing to know if you plan on bringing a straw with you to the moon. As you can see, I did not finish building the house, but this episode is really long as it is. So thank you so much for watching. I hope you enjoyed it and have a nice day.